So, probability rules have been developed in order to calculate the probability of compounds or multiple events occurring at the same time. We usually have two rules, what we call the addition rule and the multiplication rule. So, the first one that I'm going to look at now is the addition rule. So, the addition rule is just the union of either event A, B, or both in a single trial of a random experiment. And this has been subdivided into addition rule for non-mutually exclusive event and for mutually exclusive event. And these are the formula. So I'll first go for the uh, addition rule for for non, or just write ME, non mutually exclusive event. So with this one of the example will be, I'll just circle what I'm looking for on this table again. Let's say we are trying to look for the probability that a randomly selected GSE listed company will be either large, financial, or both. So we're looking for either large, financial, or both. Okay. So let's say we said large, financial, or both. This is how we apply the addition rule. So let's say now A is the event of large and B is financial. A way we can work it out is that we first do, I'm gonna come this side, the probability of event A, large. I look at the total of all the large company, which is 86. I divide by 170. Take your calculators and you should find this. And I do the same thing for the financial one, where I look at the total, which is 72. I divide it by 170. And what do we have? We have this 0.435. And the last one that I'll do is the intersection of large and financial. If you follow with me, the intersect here. It almost goes back to one of the principles that we have looked at already. So you do 42, you divide it by the total again, and this is what you get. And your next step now will be to add the 2 and remove the intersection. So which means that you have 0.5059 plus 0.4235 minus 0.2471. And remember, the reason why we're removing the intersection is to avoid double counting. And you should get 0.682, which in percentage is 68.2%. Therefore, we have 68.2% chance of finding a company that's either large, financial, or both. This is an example of non-mutually exclusive event, which means that these two events they can occur at the same time. Okay. So now when it comes to mutually exclusive event, and by mutually exclusive event we know that those are events that cannot occur together. Okay. Non-mutually, which means that they can occur together, and non-mutually these cannot occur together. Okay. So for mutually exclusive, usually the formula is different now. So let's say you are trying to find out perhaps what if the probability of selecting a random company that is either a mining company or a service company. So by just highlighting mining and service, obviously you see that these two are mutually exclusive, meaning that they cannot occur together. It's either you have one or you have the other one. You cannot have two. So we've said mining and a service company, and let's say A is mining and B is service. So following that formula, what we are going to do, I'm going to work out the P of A, which is mining. I'll take the total, which is 41, divided by 170. Then I have 0.241, which is 24.1%. And I work out the probability of B, which is a service. The total is 24 divided by 170. We get 0.141. Therefore, 14.1%. And so it's mutually exclusive, so the intersection is 0. And therefore now what you do is the union now of A, even A and B, all you have to do is just to add the 0.241 with the 0.141, and this should give you 0.382, meaning that we have 38.2% chance of finding a company that is either mining or a service company. The multiplication rule, on the other hand, this is usually to find the joint probability of an event A and B occurring together in a single trial random experiment. So this is divided into multiplication for statistically dependent event, which means that they affect each other, and statistically independent event, and then these are the formula to work them out. So let's dive in first into the stat dependent. Okay, so by stat dependent we can look at a question such as let's say, what is the probability of selecting a small retail company listed from the JAC sample? So we're looking at the small retail company. So we have small and we have retail. So this is statistically dependent, which means that the two events are depending on one another, they are affected. We are going to see later on after this video how to actually test for dependence. So we've said small and retail. So A for small, B for retail. And what we are going to do now, let's look at our formula there. This is what we're going to do. The first thing that you do, you find out the probability of B for a retail company will be the total 33 divided by 170, and the probability of a conditional A over B here, that one will be small over retail, so you will do 14 divided by 33. So if you follow the 14 divided by 33 and from there, let's just find the answers. Feel free to do and follow along. So here we have 0.1942 and this is 0.4242. Okay, then after we found those two, and then the intersection now, this will be equal to PA conditional B times the PB. So this is how you do it: 0.4242 times 0.1942. Okay, so you get 0.082, which means that we have 8.2% chance of selecting a small retail company from this large sample, because those two are statistically dependent. So statistical independence or independent means that we don't have an association between the two events. But however, this is only true under this condition here, which I'm going to write like this. So this is how we actually test for dependence. So, which means that if the marginal probability, this one, so the marginal probability of A equals the conditional probability of A, like this. So dependence is actually tested by looking at this formula. If the probability or the conditional probability of A is equal to the marginal probability of A. So now let's look at a question where we would actually test for dependence. If we asked ourselves, is company size statistically independent of the sector company? So this is what we're testing now. We're trying to see if the size is actually independent of the sector. So the way that we're going to do, we're going to choose one outcome of each of the events to put this to test. So let's say for company size, I'll just call it A equal size, and by that we choose medium. Let's see, we choose medium. And B for sector, we go for mining, for example, mining. All right, so the way we're going to test this, first of all, let's go and find out the P of the conditional of A. Okay, so this is going to be medium size over mining. So we look at the total of the intersection between medium size and mining, which is 8. We divide it by the conditional of the mining company, which is 41. Okay, so this is what we'll have: 8 over 1. So P, A, and B, we get that answer, which is 0.2824 or 28.24%. Then now let's just work out the general marginal probability of A, which is 48 divided by 170, and the answer there, this one will give us 0.1951, and this one will give us 0.2824. And from these two values here, we can see that P over A slash P, and P here, it's not equal. What this tells us is that these two are dependent. So this is how you test for dependence, by looking at this formula. Okay.